Hello, calculus fans. Okay, so let's talk a little bit about notation. There's a lot of other notations that we can use for the derivative. So we introduced f prime of x for the derivative of f of x. Now this is known as Lagrange's notation. That's named after Joseph Louis Lagrange, who is an Italian guy. So since we often write y equals f of x, sometimes we'll just write y prime for the derivative. Okay, so that's the Lagrange notation. I think we'll use this quite a bit. There's another notation, which is going to be known as Leibniz's notation, and that's named after the German Gottfried Wilhelm Leibniz. And that's where we can write dy over dx to denote the derivative of y equals f of x. And occasionally we'll rewrite this to write df over dx or d over dx of f of x. Now it's very important that the Leibniz notation should not be thought of as a fraction. We don't want to take this and break it up into pieces. Now there are going to be some times later on where we're going to do that for notational convenience, but it's not because it's actually a fraction, it's just a notation thing. So let's think about where this notation came from. We'll write out the definition of the derivative using the Leibniz notation and the increments that we talked about earlier. So dy over dx, which is the derivative, should be thought of as the limit as delta x goes to 0 of delta y over delta x. So this delta y over delta x, this is the average rate of change of the function that we're interested in, and then by taking a limit as delta x approaches 0, then we get the derivative. There's another way of using the Leibniz notation, and that is sometimes we want to know the value of the derivative at a point. Using the Lagrange notation, we just write f prime of a. Using the Leibniz notation, we'll write maybe something like this. Okay, so there's a fair number of ways to write those, and those are going to be quantities that represent the f prime of a that we use in the Lagrange notation. Now the Lagrange and the Leibniz notations are going to be the ones that we use the most often. There's another notation that comes up from time to time, and that's Euler's notation, and that's named after the Swiss mathematician Leonhard Euler. Sometimes you'll write d of f or d sub x of f of x. That's used to denote the derivative. And I actually don't recommend this notation. There are specific purposes for this notation, but we really are not going to run into them in Calculus 1. The time when they come up is when you study differential equations and then you think of the derivative as an operator, and you can use the d as an algebraic notation, and that the operator notation will help you a lot in solving differential equations. We're only going to be doing some very basic differential equations in this class, so we're not going to worry about that. So basically, we're going to stick with Lagrange's notation and Leibniz's notation, and I think it's important for us to be able to know and use both of them. Okay, that's all for now.